All right, everyone. So today we're going to be going over atomic structure. Now, before we get started, I want to ask that you guys have two things out. The first thing you'll see on the screen right here is the periodic table of elements. You'll find a copy of it on Canvas, and I highly recommend that you print out a copy so you have a physical one, because we will be referring back to this the entire school year. I guarantee that you'll get a lot of mileage out of it. So just make sure if you can, print out a copy, but if you can't, that's totally fine. It'll be up on Canvas for you to use all the time. The second thing I want you to do is to have your notebook out because we will be covering some information now that will be on your future quizzes. And I want to make sure that you guys have an easy place to get all your information written down so you can refer back to it. Okay, also, while we're going through this video lecture, I highly recommend that you do the problems with me. I find that the students who do well in the class are the ones that work out the problems with me as they go through the lectures. Okay, let's be honest. None of us really get much out of videos if we're just sitting there looking at the screen. It always helps to write the problems down, to take notes, to try things out with the person going over the information on the video. So I highly recommend that you do the problems that we do up here in the video lecture with me as we go through the lecture. Okay? All right. So with that being said, let's jump right into it. So today we're going to be talking about something called atomic structure. Now, what is atomic structure? So it's basically a fancy way of saying what an atom looks like. Okay, so an atomic structure is what an atom looks like. Okay, so we're going to be talking about what these atoms look like on the inside because that'll help us get a better understanding of how they operate. Okay, we talked about how in the last video how atoms are super duper small, that there are a billion trillion of them in a single drop of water. Okay, but thanks to the work of a lot of chemists, we are actually able to now identify what an atom looks like deep down, even though they're super small. And what we found is that atoms are made of 3 subatomic particles. Now that word subatomic sounds kind of fancy, but let's just break it down. The word sub, what does that mean? That word sub means under, right? Like submarine is a ship that goes underwater. So if it's subatomic, we have these atoms that are, or these particles that are under the atom. Basically, it's smaller than an atom. Okay, so subatomic particles are the things that make up atoms. So atoms are made out of 3 particles. The first is called protons, and they have a positive charge. Okay, and the symbol for that is going to be P with a positive sign. Now, what do I mean by positive? So if you guys have ever seen a magnet before, right? A magnet has a positive and negative charge, or like a battery. When you guys have a battery, there's a positive end and there's a negative end. Okay, and they're opposite. They have opposite electrical energies. Okay, that's what a proton is like. A proton would have positive electrical energy. There's some particles called neutrons, and they have no electrical energy. They're neutral. That's why they're called neutrons. They are neutral. Okay, there's no charge. Okay, and the last one, electrons have a negative charge, and the symbol for electrons is E minus. Okay, so these are the symbols for protons, neutrons, and electrons, and it tells us what charge they have. Protons are positively charged, neutrons have no charge, and electrons have negative charge. Okay, so let's take a look at what an atom is going to look like. Okay, so in the dead center of the atom, we have something called the nucleus. I'm sure you guys have heard that term before in biology, probably. Okay, the nucleus. The middle of the atom is called the nucleus. And the nucleus is made out of protons and neutrons. So when we have an atom, the nucleus is made out of protons and neutrons. Okay, so you might be asking, where are the electrons? Okay, the electrons, they like to hang out outside and away from the nucleus. And what they do is they fly around the nucleus. So the electrons, they fly around the nucleus. Some of them are far away, Some of them are closer. Some of them might be in between. But what electrons like to do is they like to fly around the nucleus. Okay? So I'm going to show you guys a picture that you guys have probably seen before. And it's this picture right here, the one that I have on the right side. Okay, so let's see if you guys can identify the subatomic particles. Okay, so if you want, you guys can pause the video and take a second. You guys don't need to draw this, but just look at it and see if you can identify where the protons, neutrons, and electrons are in this picture right here. Okay, the one that I drew a star next to. Okay, so pause the video, try that out. Okay, so hopefully you were able to identify where the subatomic particles are. Okay, if you guys look at this picture, in the very middle, we have the nucleus, right? This is where the nucleus is. Okay, and let's just say that the black balls right here are the protons, the positive ones. Okay, and let's say the red ones are neutrons. Okay, it doesn't matter which color you put them on. You could say the red ones are protons, the black ones are neutrons. It doesn't really matter because they don't have a color. But just know that the protons and the neutrons are in the middle. Okay, and you should have identified that the electrons are the blue balls that are flying around the nucleus. Okay? So that's generally what an atom is going to look like. Okay, protons and neutrons in the middle, and electrons fly around the nucleus. Alrighty, so let's move on. So the subatomic particles, they actually tell us about the atom. Okay, so the number of protons, it tells us the atom's element. Okay, so the element is almost like the identity, like what's the name of the atom? Okay, so identity or the name of the atom. Okay, and that's what the number of protons tells us. The number of neutrons, it tells us the atom's isotope. We'll talk about that next time. But the isotope is the type of elements an atom is. Okay, and that's what the neutrons tell us. And then lastly, the electrons, they tell us the atom's charge. So whether or not it's positive or negative. It basically tells us what kind of electrical energy it has. Okay, so the number of electrons tells us if the element is positive or negative and what type of electrical energy it has. So for today, I want you guys to assume that an atom has the same number of protons and electrons. Okay, that means that the atom is going to be neutral. So we're looking at atoms with no charge. Okay, later on we'll look at atoms that do have a charge, and then we'll have different numbers of protons and electrons. But for today, let's assume they have the same protons and electrons. Okay? Alright, so what we're going to do now is we are going to take a look at the periodic table. So just make sure you guys pull that up because we're going to be referring back to this for the rest of the class period. Okay, so we said that the number of protons tells us what element the atom is, right? And if you guys notice, we're looking at the periodic table of elements. So what we're going to be doing is we're going to be looking at the periodic table of elements to figure out how many protons these elements have. Now, we're going to be talking about something called the atomic number first. So the atomic number is the number of protons an element has. So what is the atomic number? If you notice in these boxes, there are numbers at the top of every single box, right? Okay, this number is called the atomic number. So this number 1 above H is the atomic number. This number 54 above xenon, Xe, is the atomic number. And the atomic number tells us how many protons an element has. Okay? So H is going to have 1 proton, okay, because it has the number 1 on the top. And then Xe, xenon, is going to have 54 protons on top because it has the number 54 on top. Okay, just a couple other things about the other things in the boxes. The big letter in the middle is called the symbol. It's basically a short way for us to write the element. So this H and this Xc, we call those the symbols. And there's no name right here, but the atom's name, the element's name, is usually found underneath. So the name of this atom right here is called xenon. I guess I can just write it in right here for this box, but hydrogen is going to be the name of H. Okay, you guys can either write H or hydrogen, but it's a lot easier to just write the symbol. Okay, so hydrogen is the name for any atom that has 1 proton. The name xenon is the name for any atom that has 54 protons. All right. So let's go over the practice question number 1. And again, I want to encourage you guys to do these practice questions with me. So what element has 14 protons? So what we're going to do is we're going to look for the element with the atomic number 14. 14 on top of its box. So what we're going to do is we are going to go to the periodic table. And then let's just look for the atom that has the number 14 on top. So I'm going to zoom in just a little bit, and we're going to look for the number 14. And it looks like we have number 14 right here, the number on top of the box, not on the bottom. Okay, so the answer is not going to be this one here, nitrogen, okay, because the number 14 is on the bottom. We don't care about the number on the bottom. We care about the number on the top. Okay, the number on top tells us how many protons it has. It's asking which element has 14 protons. And it looks like the name is going to be silicon, or SI, like Silicon Valley, where like Facebook and Google are. The name of that element is silicon. So you guys can either write the symbol Si, or you can write the full name silicon. Either way would work. Alright, so I'm going to give you guys a few minutes now. I recommend that you guys pause the video and try to figure out numbers 2 and 3. Number 3 might be a little bit tricky, but I think you guys can figure it out. Okay, so pause the video right here. Try number 2 and 3, and then come back to it. Okay, so hopefully you were able to figure that out while you paused the video. So what we're going to do now is we're going to go and try to figure out the answers to number 2 and 3. Okay, so number 2 is a little bit different. It's opposite. I'm not telling you how many protons there are. I give you the name of the element. It's bromine. So we'll find bromine on the periodic table. Bromine is right here on the very end. Okay, and how many protons does bromine have? All we have to do is look at the number on the top. What number is on top of bromine? It's 35. So the answer to this question is 35 protons. Bromine has 35 protons because the number on top of the box is 35. Okay, number 3 might have been a little bit tricky because here it's asking us for the element with 5 protons. So we know if it's 5 protons, there should be the number 5 on top. So if we look at the top of the numbers on each of the boxes, you'll notice, hey, boron, this element right here, has 5 protons. So boron has 5 protons because it has the number 5. But this one's a little bit different because it's asking you about 4 neutrons. So does the number of neutrons change anything? So if we go back to our notes, let's talk about what neutrons do. If we go back, what do the neutrons tell us? The neutrons tell us something called the atom's isotope, right? Are we talking about isotopes right now? No, we're not. We're only talking about the element. So this was kind of a trick question because we're not going to be looking at isotopes. Instead, we're only looking at protons. Oops, I'm like stuck. There we go. Sorry about that, guys. So since we have 5 protons and we have 4 neutrons, again, the neutrons only tells us about the isotope. We're not looking at the isotope, we're only looking at the element. So all we need to do is look at the number on top of the box. Since it's 5, our answer is just going to be boron. Okay, I've just put there to show you guys that it doesn't matter how many neutrons there are. The only thing that matters to tell us the name of the element is the number of protons. Okay, so this just kind of summarizes that. An element, it must have the same number of protons, but it can have a different number of neutrons. So what that means is that in our example, boron, it can have 5 protons and 4 neutrons. Okay, it could have 5 protons and it could have 1,000 neutrons. It doesn't matter how many neutrons there are. As long as there's 5 protons, it's always going to be boron. But if you change it to 6 protons, if you change the number of protons, the element is going to change. So now we go from 5 and now we have 6. If there's 6, it's not boron anymore, it's going to be carbon. Okay, so just make sure you keep that in mind. Alrighty, so let's do a little bit of practice. So what we're going to do now is we're going to try these two out. If you think you got it already, you guys can pause this video here and try out the problems. But if not, I'm just going to go through it step by step for you, okay? Alright, so we're going to draw a helium atom with 4 neutrons. Okay, so what we're going to do is we're going to go to the periodic table and we're going to look up helium. Okay, it looks like we have helium right here. Now, we want to first draw the middle, the nucleus. So first let's figure out how many protons we have. So helium has the number 2 on top. That means helium has 2 protons. So in the middle, I'm going to draw 2 protons. I'm just going to symbolize that with a plus sign. So let's say that we have 2 protons. Okay, the next thing that goes in the nucleus is the neutrons, and it looks like we have 4 neutrons. So what I'm going to do is I'm just going to symbolize it with an N, but we're going to have 4 neutrons. And since they're all in the nucleus, I'm just going to draw them like this. You don't need to draw it exactly like how I do it, just make sure they're all connected together. And this right here is going to be the nucleus. Okay, but we're missing something still, the number of electrons. So how many electrons do we have? So remember how I said earlier, for today, we're going to have the same number of electrons as we have protons. So since we have 2 protons, we're going to draw 2 electrons. So we're going to draw 2 electrons. Okay, and that's it. That's going to be our atom. So as long as you have 2 electrons, make sure you label them, 2 protons and 4 neutrons, you got the right answer. Alright, let's try the next one. So we have a helium atom with 2 neutrons. So this one is helium again. So it doesn't matter that we have a different number of neutrons. Here we had 4, here we have 2. Since we have the same element, that means helium, again, since it has the number 2 on top, it's going to have 2 protons. And we know that it has 2 neutrons. Okay, so in the middle, the nucleus, we're going to put 2 protons. And there's 2 neutrons, so there's going to be 2 neutrons. Okay, and then we know from earlier that there's the same number of protons and electrons, so there's going to be 2 electrons. So all we need to do is draw 2 electrons around the nucleus, and there you go. That's your answer. Alrighty. We're going to do one last problem, and then you're going to be good to go. Okay, so what you're going to do now is you're going to draw a carbon atom with 6 neutrons. So we're going to look for carbon on the periodic table. So we have carbon right here. And it looks like it has the number 6 on top. So that means it's going to have 6 protons. It says we have 6 neutrons, so we're going to have 6 neutrons. And then we said earlier, same number of electrons as we have protons, so we have 6 electrons. So now we're ready to draw our atom. We're going to draw 6 protons. We're going to draw 6 neutrons. And then we're going to draw 6 electrons around it. All right, and there we go. We have our atom. So this is what a carbon atom with 6 neutrons is going to look like. All right, so that's it for the video lecture today. I hope that it was informative and helpful. Just make sure you guys check your assignment on Canvas. Best of luck with it, and I'm still on the Zoom call if you guys need any help. Okay, so feel free to ask. Good luck, and I'll see you guys next time.